So looking ahead to this week, so we'll do 4.4 today. Tomorrow we'll do 4.5. Hopefully Wednesday we'll have 4.5 day 2 here in school. But again, weather's looking like there's a potential for a snow day on Wednesday. You just never know. Never know. But either way, you will still have a quiz this week, Friday. Okay? So regardless of what happens on Wednesday, Friday we'll still have a quiz. Okay? If you didn't take last week's quiz yet, make sure you get to the Resource Center and get that done as soon as possible. Get that ready to go. I have not graded them. My plan is to grade them yet tonight and then get them back to you tomorrow so that we're all ready to go and all that fun stuff. Okay? All right. So we're on page 13 in your note packet, in the white note packet. Looks like we got to make an equation. Looks like we got to an evaluate. A couple more evaluates. Solve for those two. Yeah, let's do that. Love that. Love this plan. Excited to be part of it. Right? Let's do the retrieval right now. 1 through 6. 1 through 5. All right, so the first one. Augustus has made a pile of 2,000 candies, and he is giving away 25 candies a day from this pile. When will he have 350 candies left in his pile? Okay, so he starts with 2,000 candies. That's this part right here. Okay, and then giving away. What? Giving away 25 candies a day, right? So how would I put that into an equation? Just straight up minus 25? X, okay? So we're going to need to determine what X is then, right? Okay, and so X is going to be, in that scenario, X would be the number of days, right? Oops. Yes? So that minus 25x there. Okay. And we want to know when his pile has only 350 in it. So what are we going to do with that expression? Equal to what? Equal to 350. Yep. Then it said, so that's our equation. So that part right there, that is writing the equation. Okay? Now we got to go and we got to solve that equation. So if I were to solve this equation, I would probably subtract 2,000 from each side. That's going to give me negative 25x. Equals negative 1650. Then I would divide both sides by negative 25. And in the end, I'd get x here is equal to, what's that going to be? 66 days? 66 days, and we have to put a label on that because we're dealing with a word problem and there's labeling going on. And that would be the solve. Questions on that one? Okay. Number 2, evaluate each function. We want to find g of 2. So that means I'm going to plug in 2 into my function. So g of 2 is going to be 2 times 2 minus 9. 2 times 2 is 4. 4 minus 9 is negative 5. So g of 2 is negative 5. Same with negative 7. 2 times negative 7 minus 9. 2 times negative 7 is negative 14. Minus 9 is g of negative 7, then would be negative 23. And it said plug those in for 8 into h of x. Same thing. So that's going to be negative 5 times negative 4, then plus 2. Negative 5 times negative 4 is 20. Plus 2 means that the value of my function h at x equals negative 4 is 22. Negative 5 times 6 is negative 30. Negative 30 plus 2 is negative 28. Questions on those four? Good.
Yeah.
Okay. Solve each of the equations for the indicated variable. We want to solve for q. So I would first divide both sides by 7 here. And that would give me r over 7 equals q. And I have it q equals, so that works out. Solving for m, first I would add 5. That would give me 2m equals y plus 5. Then I would divide everywhere by 2. So there, and there, leaving me with m equals y over 2 plus 5 over 2. Because we like fractions. Questions on those last two? Good? All right. Let's dive into some notes today. We're talking about inequalities today. Woohoo! Okay. Which one doesn't belong? Examine each of the models below and determine which one is different from the rest. Do you want to initial thoughts? Which one's different? Which one of these doesn't belong? Initial thoughts, anyone? Want to talk about it at your tables for a little bit first? Go ahead, Ken.
C.
Why?
Because other ones are like numbers and they all make sense to that, but C is just a picture.
Just pictures and blocks? Okay.
Did you put the answers in here?
When you erase it?
Yeah.
She did. Jamie did. Yeah. Yeah. She was supposed to tell you.
No telling occurred.
Okay, well. Everybody agree with Cam that C's the goofy one? Anybody got a different idea? Well, yeah. It's not an equation though, that's the problem. Do you know why it's not an equation? Doesn't have an equal sign, but it's an expression. Okay? Okay. Could we also go D because it's got multiple arrows on it? What about A? What's wrong with A? What makes A different? Side note, there was no right answer to this one. It's one of those where as long as you give a reason for it, you're right. Okay? So what would be the goofy part with A? Quick, Kim.
No, it starts at -5.
Okay. Yeah, D did too. Single arrow? Okay. I like it. All right. So, given a mathematical statement and two expressions, decide which of the two expressions is greater, if the expressions are equal or if the relationship cannot be determined from the statement. Okay? Then it says we need to write an inequation or an inequality that shows our answer to explain why our answer is correct. Okay? So for instance, okay, the statement is x, or so the statement is x equals 8, which one is greater? Okay, well, if you plug in 8 into this one right here, what do you get? 13. Okay. If I plug 8 into this one right here, what do I get? 26. So in that particular case, we would have to say that 3x plus 2 is greater than 5 if x equals 8. Right? Okay. Now, if x equaled -3. Okay. If I plug it into x plus 5, what do I get? 2. If I plug it into 3x plus 2, what do I get? -7? Yep, -7. Which one's greater then? The x plus 5 then, right? So we would have to go this way in order to get a true statement. With me on that? Okay? That's what we're going to have to justify these things. Okay? So yes, in this particular case that x equals 8, then this inequality is true. But if we change the x, our inequality then changes. Okay? So, statement number 1. N is an integer. What is an integer again? Learned about it way back in Unit 1. Integer. Just straight up, just a number. No decimal points, no fractions, no parts. Right? Yep. So just 1, 2, 3, 4. Right? Okay. Can it be negative? Yep, you can have negatives on this one too. Okay? So which one is greater? Positive n or negative n? Pick a number. Pick one. 2? Okay. So if it's 2, is 2 bigger than negative 2? Yeah? Does that happen all of the times? Okay, give me a counterexample. You think one? Going?
You just picked like -2.
So if we went, let's go off of 2 just because we just used 2. So can I go -3? Okay, all right. So if I went this way, it's that way. But if I go with -3, what's the negative of -3? +3. So then now this one would go back that way. Right? Okay. Let's see if I can find. There they are. Oops, now I gotta move my stuff. So if the integer is positive, then positive n is bigger than negative n. If n is negative, then negative n is bigger than positive n. Okay? That's the kind of justifications that we're looking for. Okay? You gotta think about these here. Try another one. The statement is x is greater than y. Which one is bigger than? X plus a or y plus a? Just had to figure out where I would start. Okay? Alright? So if we've got x plus a and we've got y plus a. Right? And we know that x is bigger. So give me an x value. 5. Give me a y value. It's got to be smaller than 5 because it already said that x is bigger than a. 3. Okay? So if I've got 5 plus a, and I've got 3 plus a. Well, let's figure out an a value. Give me a value for a. 2. Okay. So what would 5 plus 2 be? 7. Oops, I put y plus a. Sorry, my fault. 3 plus a. And a is 2. 5 is, which one's bigger? Blue or green? Blue, right? X plus a is bigger. Is that always going to be the case? Will that always be the case? As long as a is always the same, right? And a is equal to a, so a is always going to be the same. So yes, that will always be the case. Okay? That's the addition property. Talked a little bit about that. If we add a to both sides, it's going to be the same. Okay? What do you think about the next one? Which one's always going to be greater, sometimes going to be greater, or never going to be greater? Which one, what do we think? X minus a or y minus a going to be bigger? If I know the fact that x is greater than y. X minus a is always going to be bigger because this is going to be the subtraction property of inequalities. So if we use 5, 3, and 2 again, okay, so x minus a would be 5 minus 2, which is going to be 3. If we use y minus a, then that's going to be 3 minus 2, which is going to be 1, still going to be always bigger. Switch it up into multiplication. Five is bigger than 4. Is that true? Yeah, 5 is bigger than 4. Okay. So which one is greater? 5x or 4x? Do we agree that 5x will always be bigger? Why not? Okay, so let's go with an x. Can we go with an x of 2? Just keep it simple. Okay, all right. So if I've got 5x, and if I go with an x of 2, then that's 10. And if I want 4x, if I go with an x of 2, that's 8. And we still agree that 5x is bigger than 4x. Yes? Okay. Can I go with negative 3? Okay. If I go with negative 3, 5 times negative 3 is negative 15. 4 times negative 3 is negative 12. And now those change over. Okay. So this is not an always type case. This is a sometimes case. If x is 0, then they're both equal. If x is positive, then 5x is bigger. But if x is negative, then 4x actually becomes bigger. Would the same hold if we're dividing by x? Now, that 5 divided by x would be bigger if x is positive. 4 divided by x would be bigger if x is negative. Would we agree with that statement? Yay or nay? Well, let's try it. Gotta find my writing still. Let's just. Oops. Okay. So if I've got 5 divided by x, and I got 4 divided by x, let's just go with 1. So we'll go 1 and negative 1. If I go 5 divided by 1, then that's going to be 5. If I go 4 divided by 1, that's going to be 4, and then our alligator is still eating left. Okay? If I go with a negative 1, then 5 divided by negative 1 is negative 5. 4 divided by negative 1 is negative 4, and now it flips back around. Okay? Only difference on this one is we don't have that where they're equal because it's undefined. Because we can't divide by 0. need an x value and I need a y value. I don't care what they are. X is 3, y is 2, right? X is 3, y is 2. So three minus 2 and 2 minus 3. So that would give me 1, and that would give me negative 1. Yes? Okay. Let's flip it around. Let's go. X is 1, y is 4. Okay? One minus 4 is negative 3. 4 minus 1 is positive 3. Flips around, right? Okay. So what would the justification be on this one? Oh, I lied. Sorry, I forgot. I missed the first part. That x was bigger than y, so we don't have this part. Oops. Okay. So then let's go with negative. Negative 3 minus negative 2 and negative 2 minus negative 3. So that would be negative 1. This would be positive 1. Wait, did I do that right? Nope, I did it wrong still. I still have x bigger than y. Now my x's and y is screwed up. Oh well, let's just go to the justification. Because a smaller number, yep. So that's going to be an always case. Get rid of that too, because that was wrong. This one, number 7, should seem pretty easy. Which is bigger, 5 or x? As long as your x is right? As long as your x is bigger than 5, then that's going to be a true statement. Correct? Yeah. As long as your x is bigger than 5, that's a true statement. Yeah. Good times. All right, let's look at your homework here for a minute, because I want to talk a little bit about not the 4-4-3. I want to talk about the 4-4. So let's look at like number 5 here for a second. Okay? When solving the inequality, 10x plus 22 is less than 2. The second step should say that because I added negative 22 to both sides, or simply you just subtracted 22 from both sides. Agree? It's a logical step.
Mhm.
Yeah? Okay? Right? Because then that cancels out here. And then that leaves us with 10x is less than negative 20. Is what we should have, right? Because we added and subtracted. We can add and subtract just like normal and the sign doesn't flip, correct? What's the only time that a sign flips? When does an inequality, when does an inequality symbol flip? We talked about it last week. Look back in your notes. In your notes, that's white packet. Last week.
Flips one is like a negative divided.
When we divide by a negative, any other time. Multiply by a negative on both sides. Okay? The inequality flips only when you multiply or divide crazy. I think I got the E in there. When you multiply or divide both sides by a negative. Okay? So that would be your justification. That is what I'm looking for in those first couple of questions. You not only just want you to say true or false, you have to tell me why. You have to justify your answer. And you got to give me reasoning for those. Okay? Any other ones that were? So that's 1 through 7. How does an inequality compare to solving an equation? That's a good thought-provoking question. Solve for x. So on this one, if we're solving for x, and then is this value part of the solution set? So again, we add and subtract like normal. Add 9, add 9. So then that would be 2x is less than 12. Divide by 2. Do I need to flip my inequality? Dividing by 2. Do I need to flip my inequality? Why not, Kurt? Because I'm dividing by a positive number. Yep, not a negative number. So I'm dividing by a positive number. So then x is less than 6. Is x equals 6 part of that solution set? No, it's not, because it doesn't have the equals part, right? So this is not part of the solution. Okay? Good time. 10-ish or so minutes to work on some homework.